Hello guys, welcome to another section of this wonderful tutorial. In the previous video, I discussed about data types, variables, and then operators. In this video, I'm going to discuss about control structures. And for the control structures, I'll be explaining decision-making structures, looping structures, jump statements, and then nested structures. In each of the sections, I'm going to explain all the subsections under it. So what do we mean by a control structure? A control structure in C++ determines the flow of execution in a program. They actually are like a map in your code, right? So for starting with the decision-making structures, we have the if statement, if else statement, and then if else if ladder. So the if statement, let me start with the if statement. The if statements execute a block of code when a certain condition is true. Say for instance, I have about 20 students in my class, and out of these 20 students, I want to filter out those who are above 18 and those who are below 18. For those above 18, I want to print out that they are adults, and those below 18, I want to tell them they are still kids, right? So for this, I'm going to write a very basic program. So let me create a variable to represent the age. So int age. Let me initialize it to 0. I'm doing this because I want to prevent my program from reassigning a default value to age. That's why I'm doing this. Now I want to then prompt the user to enter their age. Enter your age. So when the user is prompted to enter the age, I have to get the age entered by the user, right? So with this, I have to use the cin to grab the age that will be entered by the user, and then I will assign that age to age. As simple as that. So assuming the user enters 20, 20 will be assigned to the variable age. Great. So after grabbing the age of the student from my program, I then have to write a condition that will test if the student's age is greater than 18 or below 18. So if the student's age is above 18, I want to print out that the student is an adult. So if age is greater than or equal to 18, then what should happen? So in between these curly braces is what should be executed, or what is supposed to happen if this condition here, age is greater than or equal to 18, is true. So I basically want to print out that the student is an adult. You are an adult. Cool, right? So let me start with this. Let me start explaining the code. For line 7, I'm creating a variable age and initializing it to 0 just to prevent the program from assigning a default value to it. And then with line 9, I'm prompting the user to enter their age. With line 11, I'm accepting the value that will be entered by the user, and then assigning the value to age. And then with line 13, that is where I'm making use of the if statement. So this is how the if statement works. If followed by bracket, right? And in between this bracket is the condition that's supposed to be met. This condition is supposed to return a boolean. Remember a boolean from our previous video, a true or false. So this tests if age is greater than or equal to 18. If this condition is true, I'm expecting this block of code in between the curly braces to execute. In a case where the statement is false, I'm expecting nothing to happen. So let me just print out end of program just to be sure. Done. So let's compile our code. Remember that for C++ it's a compiled language. So anytime you make changes in your source code, you have to recompile the code to get a new executable file. So gin plus plus main.cpp. Now we have our executable file here produced. To run the executable file, if you're on Windows, just write the name of the executable file, that was main, and then enter. If you're on Linux, like the way I am on Linux, you just do this. Right. So now the program is running and it's requesting me to enter my age. So let me just enter 17. So you will see that if I enter 17, this line will not be executed because the condition here will be false. Right. Now let me run the program again. Let me clear my screen and run the program again. This time I'm going to enter age that is greater than or equal to 18. So let me just put 20. And you see I have you are an adult as expected. So that is one use of the if statement. Now let's jump straight to the if else statement. If else statement. Normally the if else statement is used when you are expecting two outcomes from a condition. So with this example I gave, the condition is that if you are not an adult, you are a child, right? If you are not an adult, you are a child. So if I test if age is greater than or equal to 18 and the result is that you are an adult. Now what will be the default? If you are not an adult, you are a child. So else, what should happen? So you see that this else statement does not have a condition, right? It tells you that in a situation where this condition is not met, this should be the default behavior. The else should be the default behavior. So put it at the back of your mind that the else statement is always the default behavior of your control structure or of a series of conditional statements. So since I've made certain changes to my code, I have to save the file, the source file, and then recompile again. Gin plus plus. Let me use it. And then recompile again to see what will happen. Cool. So I'm supposed to enter my age. If I enter 12, I have you are a child, and that is what was run here. Now let me try to enter run the program again. This time let me enter 18, and it says you are adult as expected. So that is what we call if else statement. Now what do you do if you have more than two conditions, right? More than two conditions. So for that situation, you make use of the if else if ladder, right? So with this program, I can let me just copy and paste what I have here and then restructure it well. Let me clear this. So let me for this particular part, I'm going to write a program in relation to how we grade students in a particular school. So for student grading, I'm expecting them from 90 to 100 should be an A. From 80 to 89 should be a B. 89, 70 to BSc. So anything below should be D, as simple as that. I don't want to complicate things here. So with this, I'm supposed to create a variable float student score Let me initialize it to 0 as explained earlier. And then a prompt to tell the user to enter the score. And then a part to score. Now this is, so it's left with the conditions. So the first condition, I have to test if student score is greater than or equal to 90. I'm expecting just copy this line and then, and the next condition, else if. Now you see that this is an else if. It works similar to the if here. So the inside this, I have to place in the condition that's supposed to be met. So for this condition, I want to test if the student score is greater than or equal to 8. Okay, then let's just make now I just want to make this condition just 3 condition. Let me clear this here. So let me, now the last option, let me put the last option just to speed things up here. So I'm going to explain this very into details. So just listen to me very well. So the first line, I want to test if the score that was entered is greater than 90. So in a case where the score is greater than 90, I'm expecting A to be printed. In a case where the score is greater than or equal to 80, I'm expecting a B to be printed. Else, any other mark should be D. So as explained earlier, the else is the default behavior of a series of conditions. So let me run the program for you to have a feel of how things are going to be. So then let me run it. To enter my score. So the first I'm going to enter 20. Okay, let me try 89. So 89, I had a B, right? Initially to test if the student score is greater than or equal to 90. This condition was false, so the A was not printed. Then I tried the next condition, that is the else if. The test if student score is actually greater than or equal to 80. That was true, so B was printed. And the rest of the condition was skipped. That's why we didn't get B being printed. Now let me run the program again. And then this time I'm going to use print, I'm going to enter 90 as the student score. Okay, let me just use 92. So for 92, I had an A, right? So with the A, you see that the rest of the condition they were skipped, okay, or they were not executed. This is because it used else if statement. It arranges your condition like a series, right? So for the series, it checks for the first condition, second condition, third condition, and then it's trying to see if it meets any of the conditions. So if any of your condition becomes true, the rest of the conditions in the series does not execute. That is why if it takes the 92, though 92 is greater than 80, B was not printed because the sees it as a series, but rather A was printed because A was but rather this statement was executed because it was the first in the series. Now I'm going to do something here. This time, instead of else if, let me move this. Let me just simply make this if and see how the program will behave. So with this particular condition, with the first one, I'm testing if the student score is greater than 90. With this two, I'm testing if it's greater than or equal to 80. And the default behavior should be a D. So let's see this. Let me recompile the code because I've made some changes to it. Now let me run. Now this time I'm going to enter 92. Now do you see what happened? A was printed and then B was printed. This is because the condition here was true. The condition here too was true. So both statements was executed. Now let me show you the difference between the previous example and then this example. For this example, it does not see the condition arranged in terms of series, but it rather sees them as individual conditions. So for this, it tests if the score is actually greater than or equal to 90. If that condition is met, it executes the block of code in between the curly braces. It comes to the next line. Okay, it comes to the next line, then check again because it sees an if, not else if. So it checks if student score is actually greater than or equal to 80. The condition here was true, so B was printed. That's why you have A or B to be printed. In a case where you want to avoid this in your program, use else if so that the flow will be like a flow in a series form. So in a case where this is met, the rest of the conditions will not be executed. That is all for if and else if. You can pause this video and try your way around this to understand the flow very well. Now let's move on to the switch statement. Okay. The switch statement is somehow like the if and else if statement, but the difference is that the switch statement is used to execute different conditions of a particular situation. So say for instance, this example here, we want to print out the days of the week. Okay, depending on a number that will be entered. So for this, let me comment this out. Let me comment this out. So the switch statement is very easy. So switch. Okay, let me so int day. So the program will basically print the name of the day of the week depending on the integer that will be entered. So I'm starting from 0 to 6. So a day of 0 will refer to Sunday, a day of 1 will refer to Monday, and so on. So with this, I'm just making changes to one particular situation, and the situation is days of the week. So I'm using the switch statement. So switch, and then what do you want to switch? I want to switch day, followed by case. So the case is the condition. So case where is 0, case where it is 1. What do you want to do? Let me check this. Okay, fine. The case where day is 1, I want to print Monday. followed by a break. So case 2. For the sake of time, I'm not going to do up to 6. I guess this for you to understand what is happening. And then the last is the fourth. So this is, let me take you through the code. So for this particular code, I have to make sure the user enters. So for this, okay, let me just, I think I should. Wait. So let me explain the code and before compiling to see how it works. So with the switch, I'm testing different conditions for the same particular variable day. So for the first condition, in a case where the number entered will be 1, I'm expecting Monday to be printed and then break. I'll explain this break statement in a different section. And then in a case where the day entered is 2, Tuesday should be printed. And the default, this default here is like the else here. Okay, it tells you that in a case where the first condition is false, the second condition is false, the default behavior of this switch statement should be this. So you should just print out Sunday. Let's run the program. Let's compile the program to see. Great. So I'm expected to enter the day. Check if I enter 2. Okay, you see Tuesday was printed because case 2 was met. And then let me run the program again. This time I'm going to enter something like 7. The moment I enter 7, case 1 was not met, case 2 was not met. So it results to the default behavior, and that's Sunday. That's why you have Sunday printed here. This is how we use a switch statement. When we start to build projects in this tutorial, we'll be using it a lot. So just, I hope you understood this part very well. Now the looping structures. Let me comment this out. So looping structures. Imagine you are given 10 boxes, and for the 10 boxes we have just a single egg in one particular box. You are given the task that find the box containing the egg. Your obvious solution is to arrange the boxes in the form of in a chain, and then go through and then visit each box while checking what is inside until you get to the last box. You stop when you find the box with the egg, right? In this, you are repeating an event. Okay, so in the repetition of an event, to repeat an event in programming, use what we call looping structures. And the looping structures that we have in C++ are the for loop, the while loop, and the do while loop. These are the fundamental looping structures that we have. So let's start with the for loop. The for loop executes a block a fixed number of times. Okay, you understand what we mean by this. So let's jump straight to the code and see how we are going to use the for loop. So actually I'm going to write a basic program that prints out hello world 5 times, right? Hello world 5 times. So this is how we use the for loop. So the for loop, in between this bracket here, okay, you are doing what we call, you are initializing a certain variable int I equals 0, and then you are giving a condition. Then the last parameter is the increment, right? The increment part. So with this program, you are starting I from 0. You are starting your looping from 0, and then you are giving a condition that this block of code, I mean the code in between the curly braces here, the code in between these curly braces, right? That is this. You are saying it should execute as long as I is less than 5. Okay, okay, that is it. As long as I is less than 5. After every execution, the value of I is incremented by 1. Remember this increment operator when we're doing operators in our previous video. If you want to brush through, you can visit that video to see how the increment operator works. So let me just save this source file and then recompile my program. So let's see, we have hello world printed 5 times. It was printed 5 times because I started from 0. So it's like 0, 1, 2, 3, 4. The moment I got to 4, for the next iteration, I will be 5. And it will test the condition. Is 5 less than 5? No. So that will be the end of the loop. This is how we use the for loop. Right? Very, very simple. Now let's move on to how to use the while loop and when to use a while loop. So we also use a while loop to repeat a particular condition. And you use a while loop if you normally don't know the number of times that a particular event could happen in your program, right? So the while loop syntax is also very simple. You have your while and then your condition, right? The condition here should return a boolean. So I can test, I can create a variable int count. Let me start my count from 0. And my condition is I want this loop to run as long as count is less than 5. Okay. Then in between the curly braces is what should happen if the condition here is true. Great. So I just want to print I am less than 5. So I am less than 5. And then after printing this line, I want to increase the value of count by 1. So I just do count plus plus. Let me explain this. So for this, the execution start from line 51. I have a variable count which is initialized to 0. And then I have a while loop. The while loop checks if count is less than 5. So if this condition is true, it executes whatever code that it has in between the curly braces here. So I have the I am less than 5 being printed, and then in line 54 the value of count to be incremented by 1. Okay, let me compile this, save this, and then compile. It's done compiling, and now let me run. Okay, so I'm less than 5, I'm less than 5, I'm less than 5, I'm less than 5, I am less than 5 printed 5 times, because count will start from 0, 1, 2, 3, 4. See, we were able to achieve the same behavior using the for loop or the while loop, right? So you can actually use any of them depending on what you want to achieve. It depends on how you are going to structure your logic. Simple as that. That's what then will happen if I comment out this count. Let's see what happens if I decide to comment out this count. Okay, I've made changes. Let me recompile and let me run. Now see what happens. I am less than 5 is being printed several times, and this is what we call an infinite loop. I'm going to explain why this is happening. So if you are seeing this, we have just type Control plus C on your keyboard, and it will terminate. So remember, count started from 0, and I said if count is less than 5, this statement should be executed. Since count is 0, count 0 will always be less than 5. So with this situation, I'll always have this loop running. That is why count plus plus was there to increment the value of 0. So it will get to a certain point where this condition will be false, and that will be the end of the loop. So when you are using a while loop, be very, very conscious about where the loop should terminate and where the loop should run. Great. The last part of the loop is the do while loop. The do while loop is similar to the while loop, except that it executes the loop at least once before the condition is a particular condition is tested, right? So let me just copy and paste this code. Let me comment this out. So let me just copy and paste this. So let me create a variable called int x. So we have x here, so I have to create a variable called int x. So do while, so do this. So it's something like do this if while x is less than 10. This is the behavior of this is similar to the while loop here, except that this line will run once, at least once, before the condition will be tested, right? So instead of the loop running let's say 10 times, instead of the loop running from 0 to 9, it will run from 0 to 10, right? So let's check. Let me see. Okay, so we just run this. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Let me start from 1. That's so we have 1 to 9. See, the behavior is very similar to the while loop. just understand that for the do while loop, the block of code here will run at least for at least once before the condition is tested. Let me just demonstrate that behavior. Okay, let me intentionally make here one and do this less than one to confirm what I actually meant. Okay, let me save this and see. Let's all see what will happen. Okay, so in natural sense, I'm expecting a natural sense will be expecting that this block of code will not be executed because the condition says that x should be less than 1. But when we check here, x is actually equal to 1, which means this shouldn't execute. But it got executed. This statement got executed. This is because the do while loop, as explained earlier, will execute once before testing the condition. So it runs the code in between the curly braces for this do before it comes to test the condition. That's why we have one printed here. But in the situation where we are dealing with a while, the testing of the condition will happen before a block of statement is executed. So that's the main difference between the do while loop and then the while loop. And let's move on to the jump statement. Okay, the jump statement. For the jump statement, we have break, continue, and then go to. The break statement is normally used in loops and then in a switch statement. So let's visit let me comment out this code and go back to using the switch statement here. So you see, for this particular code, I use a break statement here. The break statement stops as the name suggests, it stops the execution of a program. So what it does here is that it tests if case is actually 1. So in a case where the condition here is true, this line will run, and then the break statement will stop further testing of the condition. So it stops the program from testing for case 2 and then for default. So that's what the break statement does. It terminates the nearest loop or switch. Simple as that. Now let's look at the behavior of the break statement in a loop. Let's visit, let me comment this out. And then visit the while loop. So inside this while loop, I want to break, right? I want to write a certain condition here. And the condition is that the moment count get to, if count get to 3, I want to stop the while loop from running. So with this, I have to just apply a conditional statement. So if count is equal to 3, remember the equal to operator, equal to 3, what should happen? It should break. So let me compile the code and so let's see. Now ideally we are expecting I am less than 5 to be printed 5 times. But let's see what happened here. Now we have I am less than 5 printed 3 times. This is because when counts got to 3, this block of code was executed, the break. So what the break was doing is that the break terminated the loop. it somehow tells the loop that, hey, where you have gotten to is okay, so stop whatever thing that you are doing, forget about the rest of the iterations. That is exactly what the break statement does. Get it? So let's see if I just, let me change this to 2. Let me change the condition to count is equal to 2, and let's see what happens. So now I am less than 5 printed twice. This is because count is equal to 2, which means the moment count get to 2, it should forget about the rest of the iterations. That's the break statement. So we'll learn how to use the break statement in a project that we'll be doing. Okay. Now let's move on to the continue statement. The continue statement is using loops alone, right? To skip the current iteration and move on to the next. So basically, the continue statement just skips a step. So say for instance, I'm printing the value of count. Say for instance, I want to print the value of count, right? Let me comment this out. So with this, I'm expecting count to start from 0 and up to, and then be printed up to 4. Right? That should be the behavior, the code I have here. So so I have 0, 1, 2, 3, 4 printed. But what then do you think will happen if I put a continue statement here? You just watch the behavior. You see what just happened? The moment I placed continue there, I'm just telling the program that when count get to 2, just skip that step of printing 2. That is the use of continue. So now let me just, for demonstration purpose, let me do this. Let me change this value to 3 and see what will happen. Now I would have 1 printed, 2 printed, but 3 will be skipped. So realize I have 0, 1, 2, but 3 was skipped. So that's it. You know that when you use a continue statement, you are skipping a step. When you use a break statement, you are terminating the entire loop. Great. And then goto. In modern C++ programming, the goto statement is not, like, we don't recommend you to use a goto statement, right? But let me show you how to use a goto statement. The goto state, for if you want to use a goto statement, we have what we call a label, right? So let me just comment this code out. Let me make use of the code. We have what we call a label. So let me label this run, right? Now let me clear this. And let me set the condition that if count becomes equal to 3, it should go to let's see the default behavior of this code we have here. Oh, I had an error here. I forgot to bring a semicolon. Right? I forgot to bring a semicolon. Sorry. So now you see I have 0 being printed, I have 1 printed, I have 2 being printed. But the moment count got to 3, there is this line being as go to run. All that the program is saying is that skip the rest of the steps in the iteration and then jump to run. Okay, this is the run. Now, if you want to use a go to statement, you must have a label. Okay, the label could actually be any name of your choice. So I chose run, and then with the run, what should run? This should run. So you can have several labels. I can have it as a label, std. Yes, I am eating. See, I could have I'm eating. So these are the labels and what should be executed in them. So if you have the labels, you simply have to use a go to and the label that you want to go to as we have it. So this is pretty much how to use a go to statement. So the last but not the least, nested structures. So nested structures is just combining the various control structures we have. So we have throughout the code, we have even been making use of nested structures. You see from this side, even with this part, we are making use of nested structures. With this, okay. So nested structures, we are combining the while loop. We are combining the while loop, the if statement, go to jump statement. This is the nested structure that we are talking about. So you need a combination of all this to write a very good program. That is all for this video. Don't forget to subscribe to get content like this from me.